Welcome to Trundle Town, USA, 48 degrees north. As you can see, I'm here outside Sequim, Washington, out by the Salish Sea, also known as the Straits of Juan de Fuca, which is just across from Canada. Here I have picked a straight length of road which runs almost exactly east and west to measure the physical surface distance of 1 arcminute of longitude. I measured this distance using both a trundle wheel as well as a surveyor's total station, and I used recognizable landmarks on Google Earth as well as averaged GPS positions to pinpoint the longitude of the endpoints. So you can see this landmark here is right between this telephone pole. The telephone pole is right here. This is the shadow, but the base of it is right here. My GPS, I set it on this rail, so the GPS gave an average position of right there at the point of that pin. And it's also across from this manhole cover, which you can see in the video. So that's one end. And here's the other end. I lined up to this fence line basically, and then I also averaged the position there with the GPS, and I also had the total station at this and where I measured the distance with electronic range finding to a reflector that was on this telephone pole. These 2 points are just about almost exactly 1 arcminute of longitude apart, and they run almost exactly east to west. Now let's see how many meters is in 1 arcminute of longitude at 48.1 degrees north. Alright, now I'm doing the total station electronic distance measurement part of this. As you can see, I've got my total station lined up right across from this power pole and that tree. Got my GPS there taking an average reading, and I've got the total station put above this little green mark that I put, which is where I took the trundle wheel to. 1,200 meters away, plus change, is a telephone pole where there's a retro reflector behind that truck, right centered on the crosshairs. Okay, 1,246.06 meters. Alright, here are the numbers. You can see here I have recorded both the eastbound and westbound measured meters with the trundle wheel. You can see they're a little bit different. Trundle wheels aren't as accurate as a laser rangefinder, but still, this is pretty amazing. It's surprisingly close considering I pushed it 1.25 kilometers each way. I took the average of the trundle wheel measurements. I figure that is a pretty good way to go there. So this is the average of the 2 trundle wheel readings, 1,251.3 meters. The total station, the surveyor's total station, gave 1,246.1 meters. And then using a measuring line on Google Earth between the 2 GPS coordinates gave 1,245.6 meters. And this is the west end and the east end longitude in degrees. And so I took the difference of those and multiplied times 60 to get the arc minutes of longitude between the two endpoints. And since the distance I actually measured was slightly more than an arc minute, it was 1.0035 arc minutes. Over here I have divided each of these by the actual number of arc minutes to give the actual meters per arc minute of longitude in this column here. So this is the actual meters per arc minute of longitude at this latitude as given by the Trundle wheel, and here as given by the total station, and here as given by Google Earth. And you'll see they don't match perfectly, but they match well within the margin of error of the Trundle wheel and of the GPS receiver I was using. So this very nicely lines up. So what we conclude from this is that what we're measuring matches a globe and does not match a flat Earth.